Okay, here are the solutions to the 2.2 activity, the derivatives as functions. The first question says, given the graph of a function f of x below, sketch its derivative. Okay, how might we do that? Well, what is the derivative? It's the slope of the tangent line. So at any place that we can determine the slope of the tangent line, we could actually draw a point that is on the derivative. I think the only places we can find that really easily would be when the tangent line is horizontal. And it seems like there's 2 times when that occurs, somewhere about right here and about right here. This function has a horizontal tangent line. So it means at those points, the output of the derivative is 0, which would correspond to a point on the x-axis. So there's 2 points on our derivative. And now let's think about what's happening between those 2 points. Well, our tangent lines would all go in this direction, right? It's not a tangent line, but that would be the direction of one of the tangent lines between those 2 points. And lines in that direction all have negative slope, which means all of the outputs of the derivative would be below the x-axis. And it looks right here at 0 like our tangent line would have a slope that's pretty close to 1. So it would be a negative 1, sorry. So we have a reasonable guess that this derivative goes through 0, negative 1, and it's always negative between those 2 values. And what's happening on either side of those zeros of our derivative? Well, over here, our tangent lines are going in this direction, which means they're positive. Down here, they're really steep. And what's happening up here, they're getting a little bit less steep. So they're really large, and then they're approaching 0 where they become horizontal. So here our derivative is really large and approaching 0. Over here what happens, it starts to grow. They go in this direction, and now the derivative is getting really large again. So it looks like it's really positive until it comes down to 0. Reaches a minimum there, and then again starts growing positively. So this would be a reasonable sketch of f prime of x from that graph. So we have to analyze the directions of the tangent lines and how steep they are to be able to sketch f prime of x. Okay, number 2 says, consider g of t is t divided by 2t plus 1. Find the derivative and use that derivative to find the equation of a couple of tangent lines. Okay, this is a bit of an algebra battle and it takes a little bit of patience, but here it is, it's all written out. G prime of t is the limit as h approaches 0 of g of t plus h minus g of t. So I evaluated the function at those points. In my first step from here to here, let me change colors. From here to here is to give a common denominator in the numerator. I know that's a lot. Common denominator in the numerator. And that common denominator is just this product of the 2 denominators. And multiply everything out. And again, I think as I said in the introduction video, do not multiply out in the denominator. Just leave things as they are and multiply later if needed. So we multiply everything out in the numerator. We multiply by 1 in the form of 1 over h over 1 over h. And when we do that, everything in the numerator goes away. 2t squared minus 2t squared, 2th minus 2th, etc., except in h. And so we get h over h times the product of the 2 terms that make up our common denominator. The h's can cancel, and we're at the limit as h approaches 0 of 1 divided by 2t plus 2h plus 1 times 2t plus 1. Well, the only term that's changing here as h goes to 0 is this term. It's going to 0, so that leaves the limit when it's been evaluated as 1 over 2t plus 1 times 2t plus 1, or 1 over 2t plus 1 quantity squared. So what did we find? We just found that g prime of t, the derivative of g with respect to t, is 1 over 2t plus 1 squared. Okay, how do we use that to find the equations of tangent lines? At t equals 1, we need 2 pieces of information. The first piece of information we need is the output of the function at 1. Here it is. The second piece of information we need is the output of the derivative at 1. The point that our tangent line goes through is 1, comma, the output of the function at 1. And the slope of our tangent line is the output of the derivative at 1. And we can go ahead and write this tangent line in point slope form. Y minus 1/3 is equal to 1/9 times x minus 1. Okay, I didn't include all of the details here, but hopefully you can do something similar at -1. The point you should get is -1, 1. The slope of the tangent line is 1, and that makes the tangent line y minus 1 equals 1 times x minus a minus 1, or x plus 1. Okay, the last question says, here's some function f of x squared plus x. First says find its derivative. Here we go, similar to above. The derivative is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Multiply everything out, cancel all the like terms. There's only terms with h's left. All of that should simplify to the limit as h goes to 0 of 2x plus h plus 1. And at that point we can take this limit. This term is the only thing changing because the h's are changing. It's approaching 0. And so that limit is 2x plus 1. So we just found that f prime of x is 2x plus 1. So the next question says find f double prime. Well, what does that mean? Well, f double prime is the derivative of the derivative. So f double prime would be the limit as h goes to 0 of f prime of x plus h minus f prime of x all divided by h. And so that would be the limit as h approaches 0. F prime now of x plus h, everywhere we see an x, we put in a 2x plus h. Sorry, everywhere we see an x, we put in an x plus h. We get 2x plus h plus 1 minus f prime, which is 2x plus 1, all divided by h. And so this is the limit as h goes to 0. Let's see, we're getting a 2x minus a 2x, 1 minus a 1, so those are going to go away. So it looks like we're just left with a 2h divided by h, which is the limit as h approaches 0 of 2. And as h approaches 0, 2 is not changing. So this limit is just 2. Okay, so that tells us then that the second derivative of this function is 2. Okay, well, can we do that again? Let's see. The third derivative then is the limit as h approaches 0 of the second derivative evaluated at x plus h minus the second derivative evaluated at x all divided by h. Okay, this is the limit as h approaches 0. Let's see, the second derivative evaluated at x plus h. So what do we know about the second derivative? It's a constant function. It's the constant function 2. Input x plus h, you still get 2. Minus the function itself, which is 2, all divided by h. 2 minus 2 is 0. So this is the limit as h approaches 0 of 0, which is just 0. So we just found that the third derivative of this function, sorry about that, is 0. Okay, there are the solutions to the section 2.2 activity. So see if from there you can do some of the work assigned in the homework for section 2.2.